Let's work on some of the problems for the homework for the 7.2.2 central limit theorems with RGuroo. So I have RGuroo opened and all right, let's work some of the problems from the homework. This is 7.2.2, the central limit theorem using RGuroo. So first question in here is, an ICU nurse is recording the systolic blood pressure of incoming patients. We're going to assume that the systolic blood pressure has an unknown distribution, but that it has a mean of 110 and a standard deviation of 12.5. The nurse believes incoming patients' systolic blood pressure readings are too high. If she randomly selects 40 patients and records the systolic blood pressure, we are going to use RGuroo to find the probability that the average systolic blood pressure reading from the sampling it's over 116. All right, so questions are, what is the mean for the distribution of the sample means? Notation, mean distribution of sample means. What is the standard deviation of the distribution of the sample means? And what is the probability that the mean it's greater than 116? Right, so according to the central limit theorem says that the mean for the distribution of the sample means is the same as the mean of the population. So that would be 110. All right. The central limit theorem says that the standard deviation of the distribution of the sample means is the standard deviation of the population, which is this given in here, divided by the square root of the sample size. So then when we do that, we do 12.5 divided by the square root of 40, which is the number of patients that she is selected. And that give me, so we need 3 decimal places, 1.976. All right, 3 decimal places. Again, this 1.976 is the standard deviation of the population over the square root of the sample size. All right, so now once we have those two, we need to go to RGuroo to find the probability. So we go to probability in simulations, we open the tab and we go to the calculators and we choose the continuous calculator. From here, we are given values to find the probability. So we have 116 for the value. We're working with the normal distribution. All right, so mean was 110. So that's from here, 110. Standard deviation, I'm just going to copy and paste that from one side to the next. All right, and so back here, it's greater than 116. So then this is going to be above 116. And again, I'm going to do the graph so you see what I'm doing. All right, so here I have distribution of the sample means for the systolic blood pressure. I have 116 here, and I have above, which is greater than. The probability, it's 0.001197. So let me just get this, and I'm just going to copy and paste. And then in here, it says to round to 3 decimal places. So 1, 2, 3, and I don't need all this. And that should be it. All right. So here we're using that definition for that central limit theorem that says that no matter what the shape of the distribution of the population is, the distribution of the sample means it's always normal, with a mean being the same as the mean of the population, and the standard deviation being the standard deviation of the population over the square root of n. All right, let's see what we get next. A high school track team has a grade point average of 3.36 with a standard deviation of 1.2. The coach wants to identify the team members in the bottom 33% for extra tutoring help. We're going to calculate the GPA. That will mean that the track team athlete will be recommended for extra tutoring help if the coach examines just 32 of the athletes, okay? Questions here are the standard deviation of the distribution of the means and the mean. So again, use the central limit theorem. This is the standard deviation of the population over the square root of the sample size, and sample size is 32 because that's the number of students that are being examined. I don't know if it's going to like it like that, but I'm going to leave it like that for now. And then the average GPA is 3.36. So according to the central limit theorem, the mean of the population and the mean of the distribution is the same. And then this is the mean and then the standard deviation, right? Let's see if it takes it like that. No. All right, so let's do it. Let me just find that. Let me just find who that is. So that is 1.2 over the square root of 32. 2 decimal places. So 2 decimal places will be 0.21. And then 3.36. No, why? 0.21. 3.27. Oh, yeah, I know why. This is not the mean. This is not the mean of the distribution. This is the mean of the data point. So I'm going to show you how to find that number with what we have. So we have a mean of 3.36. I'm going to back here. I'm going to go back here. So now we have a probability. We need to find a value. That value is that 3.27 that I missed. So let me just go back here. The mean, and again, everything is given to you in here. So the mean is 3.36. So here, mean is 3.36. So go here, 3.36. Standard deviation is just what I found. Is this 1.2 over square root of 32? It's 0.21, so that you need to put in here. I'm going to find more decimal places. So this is 0.212132. That is the standard deviation. All right, so then what we need the coach wants to identify the team members in the bottom 33%. So then we want a lower tail of 0.33. And so again, when we do this yellow area here that it's shaded is the lowest 33%. Everyone that it's in this tail is going to receive that extra tutoring help. And for that, you need a GPA lower than or equal to 3.27. And so this is the 3.27 in here that I missed. Right. So for notation, one is mu and then x bar as a subscript. That's the mean for this distribution of the sample means. The sigma with the x bar is the standard deviation of the distribution of the sample means. And when you have this x bar, it's actually a value on your distribution. It's not the mean of the distribution, it's actually a value within your distribution. So I can go back, right? I cannot go back. Right, let me see. Let me just do this one here. So it says a financial services company, the mean percent allocations for bonds in a retirement portfolio. So the mean is 26.9% with a standard deviation of 3.6. We're going to select the random sample of 35. And the probability that the mean bond percent for the sample will be at least 28 was determined, right? So at least 28 means greater than 28. Was the probability a left tail, right tail, or in interval probability? And then we need to find what is the actual probability. So then if it's at least 28, it's greater than or equal to, so this is a right tail because we're going to the right of 28. So it's going to be either this one or this one. And for that, we need to find the values that we need for RGuroo, right? So we go back here, we need the mean, we need the standard deviation, and then we are finding the probability, right? So then we need to back this in here because we have values to find the probability. Mean is 26.9. So here, mean 26.9. Standard deviation is 3.6 divided square root of 35. So I'll do that in my calculator. That is 3.6 divided by the square root of 35. And from there, I got a 0.6085. All right, and then now what do we need? We need at least 28%. So then we want to go above 0.28. Right, let me see. Around the again, probability that the mean 1% for the samples will be at least 28. So yes, 28%. Percent is the unit of measurement, so it's just 28 without the point. Again, I'm going to do the graph because that gives us information if we're doing it correctly. All right, greater than 28, so at least 28 or more. And then we have the probability is this one in here, 0.035. So 0.035 is this one, so this should be the correct one. So it's a right tail, and the probability is 0.035. All right, so with this central limit theorem, well, let's do this one because this one is an interval one. So when we talk about interval, a computer technician believes the upload speed offered by a new internet company in town is not as fast as advertised. We're going to assume the upload speed follows an unknown distribution. Again, remember that to apply the central limit theorem, we don't need information about the original distribution. With a mean of 38 and a standard deviation of 11. If the technician randomly selects a sample of 32 internet connections, we need to calculate the probability that the sample mean is between 32 and 34. All right, so again, who's this in here? Sigma with the X bar in the denominator. This is always the standard deviation given, which is 11, over the square root of the sample selected, which is 32. And then we need to find this probability. So for that, we need to go to RGuroo. So for RGuroo, we need the mean, which is 38. So go back here. We need a mean of 32. And then we need a standard deviation up. We need to know who this is. So again, 11 over square root of 32. And this is 1.9445. All right. I'm going to write this in here because I don't think 1.3 decimal places. So that's 945. All right. And so we go here. We need the probability in between. And then the values are 32 and 34. So 32, 32. And 34. All right, so here, so between 32 and 34, the probability is the yellow shaded region, and that is 0.3482. So that's the probability. And so 3 decimal places, so I don't need the last 2. All right, so let's see. 3, 4, 8. 3, 4, 8. 3, 4, 8. 4, 8. So this is just looks, oh no, I have 3 decimal places. All right, so let's see if I did something incorrect with the standard deviation. Standard deviation of 11 over the square root of 32. That is 1.9445. 45. So if I am doing 3 decimal places, 1, 2, 3. So this should change to a 5. If I go here, the mean is 12. The mean is 12. Mean is 38. Mean is 38. I don't know where I took that. And I do 32 again. It's 38. All right, so let's see. Mean is 38, and I have the standard deviation. And so this should be it. Right, and so 3 decimal places again. 1, 2, 3. And so this should be 9. And there we go. All right. I had the mean was incorrect in RGuroo. It was supposed to be 38, and I don't know why I did that 32. All right. So let's just go here and let's just recap in terms of the continuous probability calculator. Remember that you switch this independent of if you need to find a probability or if you need to find a value. You type your mean. It's the same mean as the population given. You type the standard deviation. Remember, the standard deviation is always the standard deviation of the population. So the given one in the problem divided by the square root of the size of the sample that is being used. Then you choose in here if you want to find probability below, above, between, or outside values. If you're finding probabilities, then lower tail, upper tail, in between tails, or outside tails. If you want to make sure whether or not you're doing it in the correct direction, just always click in the graph so that when you do it, you have this figure that it's telling you whether you are outside, to the right, to the left, in between, and that can give you a better sense of what you're doing with the problem.